Great, thank you very much. My name is Chris Vantine, Chief Technologist for the Western region at Red Hat, and I've been with Red Hat for about 11 years, working with strategic partners and customers, primarily in the Silicon Valley area. And certainly one of the hot topics with our customers is around containers. So today I'm going to talk a little bit about the business drivers, also all about containers, container security. If I have time, I'll also go into a demonstration of Kubernetes. So in terms of the business drivers, certainly as you see the industry being transformed, software is a huge part of it. Mark Andreessen had the foresight to quote, software is eating the world. I really feel that open source now is eating the world. And we'll save that for another talk. But certainly one industry that you're seeing transformed by software is the automobile industry. There's a picture of the Tesla automobile factory. And software is certainly a big part of the automation to produce these cars, but also the vehicles that are rolling off these assembly lines. There's a lot of software in it, and the ability to update the software as you go. And so for the first time, you can actually go to a dealer lot, leave that lot knowing that your car will actually get better in 6, 12, 18 months. And that's because of software updates over the wire, whether it's an improved 0 to 60 time, new applications and the center console, or better battery efficiency. Even security updates, right? They're able to send those over the wire, and in many cases, saving them millions of dollars because they don't have to do a physical recall. And what happens to an industry that rests on its laurels and stops innovating, right? The San Francisco taxi industry is a perfect example. Uber and Lyft entered that industry several years ago, and they've had a dramatic impact on the taxi industry. Ridership has plummeted by 65%, and that data is quite old. More recently, Yellow Cab, the largest provider of taxis in San Francisco, filed for bankruptcy in January. And so software had a huge impact because it transformed the user experience with the mobile application to hail a taxi and to actually pay for the taxi via automated electronic account as well. And it's also enabled them to rapidly introduce new products and services to the marketplace, providing a competitive advantage over their competitors. And so there's increasing pressure on IT to not become the bottleneck, right? How does IT become a strategic differentiator? I talk with a lot of companies, and what I notice is that a lot of these companies, their developers, their testers, and their operations are all working in silos. Right? They have different technologies, different processes. So it makes it nearly impossible to quickly move the business applications to production. Right? The business is analyzing data, maybe big data, making assessments based on customer feedback. How do they roll out new products and services quickly if it's such a chore to move an application from dev test into production? Many customers say it takes up 6, 10 weeks, and they don't have no idea how long it will take, right? How can you get it down to under 30 minutes, or more importantly, when the business needs it? And so there's a shift in IT, and many of the leading companies in the Valley are already adopting and shifting in the how, what, and where of application development processes, application architecture, as well as the underlying infrastructure. There's a shift, a movement away from waterfall to DevOps, right? DevOps is all about eliminating that wall that traditionally sits between developers and ops and allows you to quickly roll out new products and services to production in a matter of minutes rather than weeks or months. And coupled with that is microservices, right? Decomposing that monolithic application that gets updated every year or 6 months into one that's more manageable, has a lot of flexibility to scale up independently or scale down, as well as reducing the code size so that you can quickly get a new change, as well as reduce the risk of that change having a negative impact on the environment. And how do you get that iPhone-like experience when it comes to application installation and updates? Right? Containers have that promise to be able to package your application with all its dependencies and separate the user space from the kernel or the host operating system and be able to easily update. So now the enterprise can have that iPhone-like capability of easily installing applications at scale. And the promise is that you'll be able to deliver these applications faster and with improved quality. And so Linux containers, they've been around for quite some time, but the OCI, or Open Container Initiative, came together and standardized on a standard image format and a standard runtime, providing compatibility across multiple vendors, similar to the Java world, where you have your WAR file and you have your JVM, providing standardization. And so the basic premise of Linux containers is all about the build, ship, and run workflow. Build, from a perspective, you have a Makefile or Docker file, which has the blueprint for building the image, then being able to take that image and share that via a registry, so you can share it across your dev, test, and production environment, or then run it in a physical, virtual, or public or private cloud. And there are a lot of security implications with this pipeline as well. Does anybody recognize these companies? Right, these are some major brands, and why do I show them? Because in 2014, they represented over $1 billion data records that were breached due to security issues, including the White House, right? So what is the greatest security risk of these? It's employees not taking proper security measures, outside breaches, unpatched or unpatchable systems, internal attacks by a fellow employee, shadow IT, or bring your own devices. When I first got to Silicon Valley, I would talk with customers about security, and one of the common phrases was patch. Well, we have our servers behind the firewall, right? Those days are long gone. You have to patch more than just your DMZ servers. And as you adopt containers, what are the new security risks? What are the new processes you may need to incorporate? Right? So the different container security risks that you want to be aware of, kernel exploits. The kernel plays a much more important role in a container environment than even a virtual machine. And we'll talk about the details in a minute. Also, denial of service attacks. Right? You have multiple containers on the same host. If one rogue container consumes all the resources, you could have a negative impact on the other container services on that host. Container breakouts, right? Because if the kernel gets attacked, it can then have access to other containers on that particular host. Poison images, where are you pulling these images down? Are you getting from a public repository? Who built those images? What went into that image? Compromised secrets, right? If you're extracting the data and passing that to a stateless container, how are you transferring that secret? And so let's walk through some of the security implications through the typical workflow or pipeline. First off, in terms of building, right? The nice thing with Docker is that now you also have a recipe for how that image was built. How many of you have servers that were manually set up and configured, and you have no idea how to reproduce it or what went into that server once an employee left who built it, or a virtual machine? And so a Docker image provides a consistent package format across all languages, whether it's Node.js, Python, Perl, or C. Think of this as in the Java world, your WAR file or EAR file, except it's for multiple languages. And then this image contains all the dependencies in the user space that that application needs. So in the C world, it has bash, glibc. In the Java world, it has your JVM, for instance. And you need to be aware of the different dependencies it's pulling in from a security perspective as well. And then these packages can actually run across physical, virtual, public, private cloud because you have that standard runtime. Now, one of the other issues to be concerned about is the way that you're building and updating your images. In a typical traditional software supply chain, you typically have your sysadmin defining a core build using a kickstart file. And then maybe you have your middleware team rolling out the middleware, whether it's Tomcat or JBoss, using a manual tar file. And then you have the application developer deploying the actual business code in a WAR file. And so this in itself is cumbersome because each group is using its own language, its own tool to do its deployment. So one of the challenges that's overcome with Linux containers is the normalization and the language consistency across this using a Docker file. So all now 3 groups can define the host OS, the middleware tier, as well as their application using the same syntax using a Docker file. Also, from a security perspective, if I'm an application developer developing the business logic, I don't have to worry about the update to the base image for my container. I don't have to worry about an update to the middleware tier as well. And so through a parent-child relationship, I can do cascade rebuilds as well. Right? So my operations team can continue to own the core build and specify that in the Docker file. And if an image stream is updated, that could trigger an automated rebuild of my any application that depends on that core build, as well as the middleware tier as well. Now the ship part, this is where you're sharing your image. So from a security perspective, as I mentioned, you have a choice. You can use a public registry or a private registry. Most enterprises I'm talking with are setting up a private registry, so they have some controls around what's being distributed within their organization, as well as signing those images to guarantee their authenticity. And why is that important? Well, Red Hat, we did a scan of the public images, and we found that 64% of them have some sort of security vulnerability on the public repos at this point in time. 36 being high in terms of shell shock, heartbleed, or poodle type exploits. And it's not just at the time of the scan is conducted or when that image is pulled down. You need to be aware of the security vulnerabilities over time that pop up. Here's an example back to those dependencies that were pulled into the image. In the middle, on the left, we have a Java application, and it pulled in the JRE. But what you may not be able to see in that triangle is the number 66. At the time of this slide, that represented how many security notifications have been issued for the JRE since RHEL 7.0 have been released. Right? So it's important if your developers are pulling down these images to have a process to scan and be aware of any vulnerabilities over time that may pop up. And where are these vulnerabilities happening? Right? So number one is the kernel. And below that, a lot of Java packages as well. And so if you're deploying Java, you're deploying the kernel, it's very important to have some sort of system update scanning process or container image scanning process as well. And so upstream community OpenSCAP, this provides a set of tooling to do scanning on Docker images and Docker instances as well, so whether it's at rest or in runtime. It uses a security guide which provides standards around security compliance. So these are things like having a minimum length on your password set. Also, scanning for security vulnerabilities. This is where you have out-of-date RPMs that have known security issues and be able to scan your host as well as any container images for these issues and being alerted. And so OpenSCAP provides a set of tooling and daemons that you can actually run against your environment at the host or the Docker instance level and image level as well. And the end result is that you get some reports. You can have visibility into the security vulnerabilities within your images in your registry, as well as any security compliance issues. So maybe you have a checklist defined for your environment, maybe ensuring that legacy services like Telnet-D are not enabled, password criteria is set and configured properly as well, and if not, alert yourself. And so the OpenSCAP community has a set of tooling to help you identify, scan, and report on those. And the last part is the runtime, right? The ability to run Docker images across any environment, physical, virtual, public cloud. And one of the key things to note is the difference as you move from a virtual world to maybe a container world that can run on physical or virtual. In the virtual world, you have a VM with its own kernel and its own set of shared libraries across those applications sitting on top of a host with another kernel, right? So there's multiple layers of protection and isolation. Whereas in the container world, you have a single kernel being shared across all containers on that host. And then each container packages in its own dependent libraries as well. The advantage here is that you could have, for instance, a RHEL 6 and a RHEL 7 container running side by side on top of a RHEL 7 host. But from a security perspective, it's important to note that, hey, if I break into that kernel, I might be at risk of one container being vulnerable to another container. And so that's where you need to make sure that you have the right processes and the right technology in place to isolate that as best as possible. And so in the Linux kernel, there are some key technology. C groups provides resource control, memory disk, CPU, et cetera, so that you don't have rogue processes over-consuming. Also namespaces, providing the look and feel of its own complete operating system and providing the ability not to have conflicts for user IDs or group IDs. And then also SC Linux. How many of you disable SC Linux on a system? Right? In a container world, you got enable, right? So the reason being is that you need to have the extra level of security so the process can only communicate with the objects it's been defined to communicate with and have access to. And it's very important to provide that extra level of security in a production-like environment so you can have different business units sharing the same infrastructure and ultimately then reduce your costs by leveraging resources to their fullest utilization, regardless of the application running on top of it. And so in terms of security, you have a lot of options. I would say one option is security by luck, and I do see this sometimes. Just running an unsupported distro, not patching that. Also running systems that are end of life. CIO of a major Silicon Valley company told me, who've had several public break-ins, that their break-ins are typically because of that one system that's on a very old OS, and it didn't get patched, yet 99% of their other systems did get patched. So it's important to be comprehensive in your process to security. Also, security by firewall. This was very typical, I'd say 5-10 years ago. We only patch our systems in the DMZ. Right? We all know with all the latest news articles about security breaches, it's very important to take security seriously. And so here are some recommended practices in a container-based environment. Use a supported distro, have a patch management process in place for your host as well as the containers. Use trusted containers as well as using trusted content. Right? Know where you're getting that content from. Also, have a container scanning process. Incorporate that in your CI/CD process if you're adopting DevOps. And then also make sure SE Linux is set into enforcing mode. Right? And in Red Hat, we provide that out of the box. And so I mentioned incorporating that into your CI/CD process. Right? So if you're adopting DevOps, here's a typical flow to do CI/CD. CI/CD is all about automated builds and automated deploys. And some of the key things from a security perspective is, hey, when I'm doing a Jenkins build, trigger an automated security scan. Use OpenSCAP, right? Check your image. If it fails the security check, don't go any further in your pipeline. Also, incorporate a private image registry. Sign your images. Know where they are trusted or not. And then the other component is automated deploy. That's where Kubernetes comes in. Right? Kubernetes is a container scheduler and orchestration solution from Google. They've had over a decade of experience and knowledge with containers. And they've open sourced their container management technology into an upstream project called Kubernetes. Provides the ability to deploy applications, manage the life cycle of those, including things like rolling updates, taking care of network IP service discovery, as well as pulling down the Docker image and creating the instance for you so you don't have to, as well as managing shared secrets. So from the automated build perspective, at Red Hat in the OpenShift upstream project based on Docker and Kubernetes, we've added additional developer-focused capabilities to really focus on the automated build aspect, right? Abstracting the developer from containers, letting them focus on the code. And part of that is automating that pipeline. And so in this pipeline, from a security perspective, add a stage to do a security check, right? Make that automatic, ingrain it in your process within your organization, whether it's OpenSCAP or some other tooling. Make sure that you're scanning your images so your developers don't have to worry about it. It's just incorporated into that. And that requires operations, getting up and bridging the gap with developers and understanding their workflow and bringing to the table that security cap and showing how you could actually automate that process to scan those images so it's not cumbersome from a developer perspective as well. So automated builds. Kubernetes provides the automated deploy aspect. And this is key from a security perspective because you're not going to go out and patch all of your container images, right? That breaks the whole model. The model with containers is you package it once and then you deploy anywhere. That means move that application as is from dev, test into production, right? Don't reinstall, reconfigure it, right? That means it didn't go through the testing process. It didn't go through your security scan. In a container, in a shipping perspective, you don't package the container at the shipping dock. You package it in the factory because at the shipping dock, if something breaks or doesn't fit, you have to go back to the factory, and that's very inefficient. Right? Do it at the factory and then never take it out of that container through its life cycle. And so Kubernetes provides the ability to automatically deploy your applications and to automate that process so that you can efficiently move an application from dev test into production and production at scale in an automated manner. So when there is a security issue, rather than patching all those containers out in the production environment, you instead rebuild a new version that addresses those security issues. And perhaps that rebuild was triggered automatically through the cascading rebuild because it detected there's a new core build that my application pulls in its Docker file. And that's managed by my operations team. Yet as an application developer, I automatically got a notification, hey, it's time to rebuild. And I could have that automatically set up so that then moves that application through a new build pipeline. Once it passes, including the security scan, it moves into test. Once it passes, it then gets automatically deployed. And Kubernetes can handle that for you. Here it shows deploying a front end and a back end. It went ahead and passed along the username password secret as well, stored in etcd. Assigned an IP address. As a developer, I didn't have to worry about that. And then also, as I deploy a particular version, version 1, in this CI/CD world, DevOps, where I'm going to have to constantly deploy new versions, I have to have this automated build, automated deploy, and Kubernetes can handle that for you to lower the risk of the upgrade process. And so in Kubernetes, I could have a virtual view of my test environment. I'm going ahead and testing and building version 1.2. Once that completes the CI testing process, including that security scan, I can then automatically deploy and switch the traffic over to that new version. And so Kubernetes will take care of a software load balancer being set up, the new IP addresses of the container images instances being mapped to that load balancer and the traffic routed accordingly. If there's an issue with version 1.2, I again can automatically roll back to version 1 if I'd like to. But more likely, in a CI/CD world, you're just going to rebuild and deploy the next version to address that issue. And so from a container best practices around security, here's some summary of some recommendations. Only run container images from trusted parties. Container apps should drop privileges, right? A lot of container images require running as root. You want to see about running that, dropping those privileges. Host operating system matters, right? There's a bind between Docker, Kubernetes, and the underlying operating system. Make sure that you're applying these kernel security fixes. You have a process and tooling to automate that because the kernel is a critical component in a container-based environment. Again, don't disable SE Linux. At Red Hat, we provide policies out of the box for a Docker-based environment in the operating system. Also examine container images for security flaws. So have that tooling, have that process in place, incorporate it into your CI/CD. Have an automated build and automated deploy. Right? This ensures that you have a robust software factory that can quickly upgrade and roll out new versions as issues come up in your environment. And that's all I have today. So thank you very much for attending today's session. Feel free to reach out to me on email. I'm also available on LinkedIn. Again, Chris Vantine and cvantine@redhat.com. Thank you so much.